A company generates a 4-character code using the 26 letters of the alphabet and 10 digits from 0 to 9. So we have 26 letters and 10 digits, right? 10 digits. The code is in the form letter, digit. So we can see that we are alternating. We put a letter, a digit, a letter, a digit. For example, we can have a code like A1M9. Do you get it? Right. And then, but there's a lot of them that we can make, right? Now let's look at the first question, 12.1. They want us to determine how many different codes can be formed if letters and digits may be repeated. Which means if repetitions are allowed, our number of choices to choose from does not change. Ne? So basically, the repetitions being allowed, it means I have 26 options here to pick a letter. And I also have 26 choices there. For example, I can have a code like A1, or A whatever, A7, you get it. B1, B2, you get it, because repetitions are allowed. So my options always stays the same. And also with digits, I always have 10 digits and 10 digits. And then multiplying 26 times 10 times 26 times 10 should give us 67,600, which is our answer for 12.1. All right. Now let's look at the next question, which is 12.2. So they say determine how many different code can be formed if the letters D, F, I, Q, U, and V may not be used. How many are they? It's 1, 2, 3, 4, 5, 6. So we cannot use 6 of them. So which means our letters now reduce to 20. So we have 20 letters and 10 digits so far, right? The code may not start with W or Z, which means here we can only have 18 options on the first part because we further cannot start with the W or the Z. So out of this 20, we need to take W and the Z out for the options that we can start with, which means the first letter choices are 18 letters. Yeah? Okay? And then they say the code, okay, the letters or the digits may not be repeated. Yeah? So we cannot repeat. Okay? So which means here on the letter, let's deal with the letters. Yeah? We can now take back those W and Z. Yeah? But because we already used one option here, we are going to be left with 19. Does make sense, ladies and gentlemen? I picked one letter, so I'm left with 17 letters in the meantime after picking one out of 18. And then, but because the W and the Z can now come back here I'm going to have 19 options to put. All right. Remember, we already chose one letter for the first place. So the remaining letters will be 20 minus 1, which is 19 choices. Okay. Now, they say the code ends with an odd digit. Yeah? The code is going to end with an odd digit. Odd numbers is 1, 3, 5, 7, and 9. So it's 5 of them. So which means here we have 5 options to pick from. Right? And then, because I used one of the numbers between 1, 3, 5, and 7, the other 4 are still remaining. They are going to join the other 5 even numbers, which give us 9 options here, since repetitions are not allowed. So that fundamentally, according to fundamental counting principle, will just be 18 times 9 times 19 times 5, which becomes 15,390. Right, ladies and gentlemen. Now let's come to this part. They say the company wishes to increase the number of 4-character codes formed in the question 12.2 by allowing the letters to be used. Calculate the percentage increase in the number of different codes that can be now formed. So there is one condition that changed. Ne? So which means, let me open my brackets. My digits are still governed by the same condition. So which means if I take all these things back, it means I have 26 options to pick from. Ne? 26 letters in total. But to begin with, I need to take W and something out. What was W and Z? So I need to take, to start, I can only pick 24. Ne? So I have, out of 24, I pick one option. So how many am I left with? With 23. So from that 23, I can now add these two guys back, because here there's no condition. So 23 plus those two guys, I will now have 25 options to pick from. So here I have 25. And multiplying all those together will give us 27,000 options. And then to get the increase, remember percentage, they needed percentage increase actually. Percentage increase will be a positive difference over original. It's always divided by the original multiplied by 100. Ne? So now the positive difference will be 27,000 minus 15,390 over the original, which is 15,390 multiplied by 100. And when we press that on our calculator, it should give us 75.44%. And that's it with this question, ladies and gentlemen. Boom! That's how you handle code questions like a legend. Remember, take restrictions one at a time, multiply your choices, and keep those calculations neat. For more killer tutorials like this, please like, subscribe, and remember, maths never sleeps.